Scope 3 pressures drive demand for recycled ABS. Recycled plastics offer measurable carbon savings. As manufacturers look for near-term ways to lower supply chain emissions, recycled acrylonitrile butadiene styrene (RABS) resins are gaining attention as a proven Scope 3 reduction lever. Life cycle assessments consistently show that mechanically recycled plastics consume far less energy and generate significantly lower greenhouse gas emissions than their virgin counterparts. And ABS, one of the world's most widely used engineering thermoplastics, is no exception. According to the latest forecast data, the global RABS market is set to grow from $1.7 billion in 2025 to $3.3 billion by 2035, expanding at a 6.9% compound annual rate. Comparable external estimates place the same market between $1.57 billion 2024 and $3.34 billion 2034, indicating a broadly aligned growth trajectory of about 7 to 8% annually. That scale of expansion reflects both regulatory drivers and the practical climate accounting benefits of substituting recycled for virgin feedstock. Why RABS matters to Scope 3 inventories. ABS, a blend of acrylonitrile, butadiene, and styrene, is prized for its strength, surface finish, and dimensional stability. Those same properties make it a major contributor to automotive and electronics Scope 3 emissions, since virgin ABS production is energy-intensive and petroleum-based. Recent life cycle analyses by Franklin Associates, the Association of Plastic Recyclers, and other research groups show that using mechanically recycled plastics instead of virgin materials can reduce cradle-to-gate energy demand by 30 to 50% and carbon emissions by 40 to 80%. Depending on the recycling route and contamination level. When applied to high-volume ABS components, from dashboard assemblies and door panels to monitor housings, those savings translate directly into measurable supply chain impact. For automotive OEMs, electronics brands, and appliance manufacturers with ambitious emissions reduction targets, integrating verified post-consumer or post-industrial ABS content has become a quantifiable Scope 3 quick win. Applications where recycled ABS performs. The automotive sector already accounts for roughly 35% of global RABS demand, with interior parts such as instrument panels, consoles, and trim pieces making up more than half that share. Electronics housings represent another 25 to 30%, driven by extended producer responsibility programs and eco-design standards in Asia and Europe. High-grade mechanical recycling and quality assurance processes now allow RABS to meet many of the same durability and aesthetic requirements as virgin resin. Chemical recycling, though still small in volume, is emerging as a route to restore polymer chains and achieve like-new performance for applications with stricter specifications. Digital traceability and regulatory momentum. Policy is reinforcing the market trend. The European Union's end-of-life vehicles regulation under revision will introduce minimum recycled plastic content in new cars, while the Eco-Design for Sustainable Products regulation, ESPR, will require digital product passports documenting material composition and recycled content. Together, these rules are expected to accelerate adoption of recycled resins, such as RABS, across manufacturing supply chains. In parallel, corporations are deploying digital material tracking and supplier validation tools to verify recycled content claims, an essential step for including RABS substitution in audited Scope 3 disclosures. Many procurement teams now treat recycled resin sourcing as a form of embedded carbon contracting, where carbon and cost data are managed side by side. Challenges: consistency and feedstock supply. Despite the upside, barriers remain. Maintaining color uniformity and mechanical properties across recycled batches is complex, particularly when blending post-consumer feedstock from multiple waste streams. Feedstock scarcity is another issue. Only a small fraction of global ABS waste is currently recovered due to collection inefficiencies and additive contamination. Investment in advanced sorting, debromination, and polymer restoration technologies will determine whether RABS can meet stricter performance specifications at scale. Industry collaborations, linking recyclers, compounders, and OEMs, are already underway to close that quality gap and build verified material pipelines. You've been listening to Sustainability Soundbites presented by E+E Leader. For partnership opportunities, reach out to a member of our team.